So now we're going to talk about data models. So how can we store GIS data? So digital spatial data sets are going to be maps in electronic format. So geographic information in electronic format, which is going to include the map and also a table. So in the data models are going to be the formats in which we store that data. GIS data can be extremely complex. There are many different types of GIS data. I'm going to refer here only to a few. We're going to work with vector data. Vector data is data that is represented by points, lines, or polygons. That is vector data. Raster data is going to be represented uh, by pixels, just like our TV. And the smaller the pixels, the better the description of the terrain would be. We also have TINs, that stands for triangular irregular networks. And we also have images that can be used as background. Many of these types of data have already been used in many of the applications that we have, and all the maps that we use for navigation. They have images, they have raster data. So these are no concepts that are completely new to us. So as I said, vector data is going to consist of points, lines, and polygons. Raster data is going to consist of a mesh of pixels. So you can see in this image, where I'm moving the cursor, the image appears to be a continuum. However, when you zoom in, if you see carefully in this other image, you can notice the pixels, and uh, there are no changes within a pixel. All the pixels are uniform. So if you want to capture variability, what you need is smaller pixels. Another way of representing uh, the surface of the Earth is with TINs, as I said, triangular irregular networks. These TINs are usually used to describe the topography. So the topography in certain points is captured, and then those values are connected by triangles. Obviously, it's more complex than that, but just to give you an idea. So whenever there are a lot of changes in the topography, for example, whenever you have hilly terrain or changes in the elevation, you have to measure the elevation at relatively close points, and therefore you end up having relatively small triangles. Whenever you have flat terrain, then you don't need to measure uh, points that are close. So in those cases, when you connect them, you're going to have uh, big triangles. So that's one of the advantages and disadvantages of TINs, that they have a resolution that adapts to the terrain, but that also makes working with them more complex than what it is working with raster data. We also have images. Images should be georeferenced so that they can be displayed exactly in the right location. There are different image formats that are supported. You can have JPEGs, TIFFs, BMPs. I could even display my picture there. Obviously, it wouldn't have a projection, so it wouldn't know where to put it. So I would put it most likely at a 0,0. But in terms of Being able to display just any JPEG or TIFF or BMP, that is always possible. Now let's start talking about vector data. So let's go into more detail with vector data. So the word feature is a term that is used to refer to points, lines, and polygons. So a feature can be a point, a feature can be a line, a feature can be a polygon. We use the word feature for two reasons. One is to save time. Instead of saying points, lines, polygons, instead of using three words, we just want to use one. That doesn't seem to be a good reason. But another reason is because sometimes we have what is called complex features, like multi-points. Several points are actually going to be treated as a single entity, or multiple lines are going to be treated as a single entity as well. For example, if you have a street that suddenly stops and then continues at the other side of a lake or at the other side of a golf course, so you have actually two separate lines, but you would like to treat them as one single street. So in those cases, we have a complex lines. We can also have complex polygons. For example, if we have a map of the United States, we would like to have one feature, one entity per state. So when it comes to Hawaii, we don't want to have a separate polygon for each island, and we don't want to choose just one of the islands. We would like to have all the islands. So in order to uh, do that, we define a complex feature, a complex polygon. So we don't call it polygon, we call it feature. So all the Hawaiian Islands are going to be just one single feature. Texas, with all the bar islands, are going to be just one single feature. So we use the word feature to refer to points, lines, and polygons that sometimes are complex points, complex lines, or complex polygons. For example, in this case, uh, I'm using the city data, so we can see that there is a point, in this case it's a simple point, a point associated with a single record in the table. In this case, we have one single line associated with one single record in the table. And in this case, we have one single polygon, the polygon of Texas, associated with one single record of Texas. So there is a one-to-one relationship between features and records. Remember, the features can be complex features. So I'm not saying there's a one-to-one relation between a polygon and a record. No, I'm saying a feature and a record because that feature can consist of more than one polygon. How are the lines and polygons created? The software does not have the capacity of drawing curved lines. So what it does is it connects points with straight lines. And if we define enough points so that when we connect them, the line ends up looking like a curved line, that's even better. But if you zoom in, you're always going to see straight lines. For example, if you want to capture the complex shape of the Mississippi River with all its meanders, you will have to put a lot of points. Those points are actually called vertices, so that when you connect them, you are capturing all the meandering shape of the river. The more vertices, the more detailed your map is going to be. The first and last points are called nodes All the ones in the middle are called vertices. How many vertices can you put? Well, obviously you can put as many as you want. You're usually digitizing with a paper map as background. Depending on the scale of your map, if it's a very detailed map, you will be able to locate more vertices. If you're drawing a map of a little creek in Austin, and the paper map that you have is a map of the United States, probably that little creek in Austin cannot even be seen. And if it can, it's probably just a little straight line. So if you want to develop a map of a little creek in Austin, probably you need a map of the city of Austin or that neighborhood, so that with a clear description or picture of the creek, you're going to be able to define more vertices. So that is why the data is associated with a certain scale. The scale is the scale of the paper map used for digitizing the electronic map. These are what I was saying, complex features. For example, you can have multi-points, several points that are going to be treated like a single feature, or you can have complex lines, lines that intersect, defined in a vertex when they intersect, or they can also be separate entities, or they can also intersect without defining a vertex. So all these are going to be different types of multiple points of complex lines. And then we can also have complex polygons. So we can have two polygons that are separated, like I referred to the Hawaiian Islands, several polygons, they are all part of the same state. So we want all those to be just one feature. Or you can have separate features, separate polygons that overlap, partially overlap. One can be hiding behind the other, depending on your legend. So in those cases, you have to keep in mind that what you see is not necessarily the real thing. It might be different. Some polygons or part of the polygons might be hiding. Vector data formats. How can we store vector data? We can store it in as shape files. We can also store it as feature classes. So we're going to end up this video here, and in the next video, we're going to need you to open File Explorer so that we can find our data in the File Explorer.